We want to teach students how to formulate hypotheses, referencing prior research and knowledge. So we've been doing many different experiments already in science. This is about week 7 or 8 in our science class, and they're familiar with the scientific method. However, we want students to create their own type of controlled experiment. So before we even begin this controlled experiment lab, we actually have students read and watch a video about a lab that tests the effects of music on plant growth. So students are already seeing some research on this topic, and they've seen some ideas on this topic as well too. The next day, we actually give them a chance to research different liquids, and they have to speculate how those different liquids will affect plant growth. For example, they're going to research lemonade, coffee, Coke, Monster, and Gatorade. And they have to figure out what's in these different liquids and how these different liquids can affect the plant growth. And what we do is we put students in small groups, usually 3 to 4 students, and they use their Chromebooks to do the research, and they must get that research checked by a teacher before they can move forward. And once they're done with that research, they have to turn it into a hypothesis. Usually we have a format in the if and because. So if I add this liquid to a plant, then I expect this to happen because of the research they just did. So for example, a student might say, if I add Gatorade to my plant, then I expect my plant to grow more because Gatorade has sugar in it, and sugar helps plant grow. If they do not have all those elements in their hypothesis, they cannot move forward in their experiment. Next, we want to teach students how to conduct a controlled experiment to test that hypothesis. After students have done all their research and set up their hypothesis, we want them to actually set up their controlled experiment. And we like to begin with the end in mind. So what me and my co-teacher do is we show them the final product, which kind of looks like this right here. I have 2 petri dishes, one labeled Gatorade, one labeled water. You see that filled with 20 ryegrass seeds. And we ask the students, how do we get from all these materials to the final product? So this is with the end in mind, and I kind of show you what we show them when they begin to design their experiment. So here are some of the materials that we use in the lab, and after we show them the final product, we really spend a good 30 to 35 minutes having students develop a procedure for the lab. We have them go into great detail, and students have to have every single step checked by a teacher before they can begin to set up their experiment. So just to emphasize, if they do not have the procedure set up correctly, they cannot even begin to start the lab. Next, we have students collect, organize, and analyze data accurately and precisely. So week 7 or 8 in class, and basically we've done a lot of practicing creating graphs, analyzing graphs, and making conclusions for those graphs too. And we also spend time assessing that stuff on a weekly basis. Here's an example kind of question that we analyze. Here's a graph about plant growth with and without fertilizer. Simple graph like that. Students have to look at, analyze this graph, make conclusions from it as well too. So it's a little trickier. We give them a graph, and this is kind of something that they've been practicing about, and they actually take this graph and they turn it into a data table. So it's a little bit trickier for them to kind of work backwards to see how the data table and the graph correlates. Another example we do is we take some data and we have students take some data about the effect of water and salt water in the growth of grass. And once again, we have to make a bar graph and a line graph. So we're practicing, making graphs, analyzing data. We've done that a lot in class for the past 7-8 weeks. All the labs have kind of had that material or have the type of stuff in it that we've done the past 7 weeks. So by the time they get to this part in the lab, they should be able to do this independently by now. Once again, they need some help, but they are in small groups. And in their small groups, really encourage students to help each other create their graphs and to make conclusions from their own graphs as well too. Lastly, students will use available technology to report, display, and defend to an audience conclusions drawn from their investigation. Now comes the fun part, taking their whole lab report and putting it into available technology. Our students have access to a Chromebooks on a daily basis, and we taught them how to get this template of a Prezi. Basically, a Prezi is a, kind of a PowerPoint on steroids, what would I call it, but it's really nice and neat, easy for students to navigate and easy to use. So they figure out how to get this onto their Chromebook, and basically they take their written lab report and just filling it into the technology you see right here. They have the introduction, they've researched this stuff, what is grass need to grow, how much water needs to grow on a daily basis. Pretty simple, straightforward here, right? They're just taking a lab report and filling in, what they have in front of them. And this stuff we'll be doing all throughout the entire year. So we expect them to do this independently, and if they need help, they just ask their lab group for help. All the materials right there, which we've kind of re-emphasized and gone through that with them. Procedure step by step. Put a data table into their Prezi. Put a graph that they've organized into their Prezi as well too. And the conclusion, we really spent a lot of time with this part right here. The hypotheses were supported or rejected. We make them use exact data from their lab. So their answer might say hypothesis was supported because on day 3, my plant grew 3 centimeters, whatever the case may be, but they have to use specific numbers when supporting or rejecting their hypothesis. Making the conclusion, stuff we've done all year once again. And last part, what did they learn from this lab? What errors they made? How can they fix their errors? And how does the lab relate to biology class? And basically a future experiment I can do with graphs would be. In this part over here, they would put a different hypothesis and a different prediction. Or some students might even explain, what went wrong in their lab and why it went wrong and how could they fix that in a future experiment. So pretty fun there for them to do that, get them kind of thinking outside of the box, and that's it. So pretty fun, pretty easy for them to use. And as the year goes on, we will basically take this template away and have them do this even more on their own and independently with their own design experiment. So, that's kind of it right there in a nutshell. Ideally, we would love it if our students did this independently on their own, but we know that's not the case yet. They're not quite there yet. So we give them a little bit of guidance. They all get this nice little handout, and basically they start their research right here. And at the bottom of that page, you can see the items they get to choose from. Now, with these items, we make it kind of competitive. We have whatever first group gets the research done first gets to pick their item. And so they have to have a lot of detail, exact numbers, exact data in their research, and they have to kind of prove to us that they know how that, or predict to us how that substance is going to affect the growth of their grass. Also, we have them make their own data table on their own, no help from us, blank piece of paper right there, and they make their own graph on their own too. So they do not get to ask us for help with that. They have to use a lab partner for that, and it's kind of the first time they've done that on their own. Students really need to be excited and engaged with this stuff, otherwise it's going to kind of fall flat. But because we've been working in groups, all year long, it works out pretty nicely that they get super engaged and super excited, and the end product is they get to present to their classmates their findings in their Prezi. So it's a lot of fun. It's a great experience for us and for them. And there you have it, how to design a controlled experiment using growing grass as your template.